The potential energy of the mass of water at the top of a hill or dam transfers into kinetic energy of motion as it falls and gravity pulls it down. Kinetic energy is converted into electricity through a turbine generator. Electricity is the flow of moving electrons. When the electrons flow, it's called an electric current. Electricity and magnetism are closely related. Flowing electrons produce a magnetic field, and spinning magnets cause an electric to flow.
This is an introduction to the importance of electromagnetic induction. If you ever drove a car, you will know the motor of an engine relies on all sorts of fields, one being the magnetic field, which in fact rotates the coil itself. The engineering behind this motor is heavily reliant on magnetic fields and currents. In fact, all substances respond to the magnetic field, even us. Magnetic fields also give rise to currents, which we can predict the direction of using Fleming's left-hand rule. The first finger being the magnetic field, a second finger being the current, and a thumb being the thrust, the motive force. So how does a coil rotate in an engine? Here's a brief example, but with a wire instead. If we were to take a wire which has a magnetic field going into the plane, which can be seen by the small crosshairs, and we were to physically move that wire downwards, then a current will flow to such as to oppose that force. In other words, a current will flow that will tend to cause the wire to go in the other direction to oppose the force that's causing the current in the first place. Which means if you use the left-hand rule, you've got the force going upwards, the resistive force, and the field going inwards, which will mean the current will flow to the right, as you can see. But suppose it didn't work like that. Well, we'd have an infinite motion, a phenomena which just isn't possible. Why, you say? Let's say the current moves to the left, reinforcing the force instead of opposing it. Then we would jerk the wire downwards. A current will flow to jerk the wire down even more, which in turn will cause a greater current, which will make the wire move down even more, which will produce an even greater current, which will cause the wire to move down even more, until there is a never-ending occurrence. Hence, an old chap called Heinrich Lenz deduced that this cannot be the case, giving rise to Lenz's law.
It is important to understand that a generator does not actually create electrical energy. Instead, it uses the mechanical energy supplied to it to force the movement of electrical charges present in the wire of its winding through an external electric current. AC power plugs and sockets are devices that allow electrical operated equipment to be connected to the primary alternating current AC power supply in a building. Electricity flows in two ways, either in alternating current AC or in a direct current DC. Electricity or current is nothing but the movement of electrons through a conductor like a wire. The difference between AC and DC lies in the direction in which the electrons flow. In DC, the electrons flow steadily in a single direction or forward. In AC, electrons keep switching directions, sometimes going forward and then going backwards. Alternating currents is the best way to transmit electricity over large distances.
Yeah.